welcome to ISTA 2014. Thank you for being with us today. For our keynote session, please welcome on stage Björn Goerke, Head of Technology in SAP.
Thank you. Thank you very much. Good morning, everybody. My name is Björn Goerke. I'm heading technology development at SAP. We're one of the main sponsors of this event. And it's my great pleasure to be here this morning at the main day of ISTA 2014 here in Sofia. So my great pleasure being here and seeing so many people, and those who stand there on the side, they're still seating here on the right side if you want to take a seat. Let me really quickly introduce what SAP is about and what we're doing. We're the leading enterprise software company in the world. We have more than 260,000 customers worldwide for our products, ranging from large enterprise companies, the big names like Nestle, Coca-Cola, brands that everybody knows, down to small and medium businesses and small businesses as well with our solutions, so a broad range of solutions. As you can imagine, a lot of that software is running mission-critical systems and infrastructure for those customers. So quality of software and keeping it up and running is one of the utmost priorities of what we're doing in software development at SAP. We have more than 69,000 employees worldwide. We have one big development lab here in Sofia with more than 650 developers to date. We just earned the Ian Hewitt Award for Best Employer in Sofia, and while we have been in the top rank, the top 3 over the last 4 years, we're very proud that we're now on the #1 position with that award. Just to give you some other idea of how relevant SAP software is, if you look at any business transaction that is happening in the world, so if you draw your Coke from a vending machine outside, or if you order something from Amazon, or if you download a song from iTunes, there's always SAP solutions part of the business transaction going on. And we're touching more than 70% of all the business transactions that are happening worldwide. So the impact we're creating with our software is quite relevant. And that's why also software quality, and that's why we're here today, is so important to what we're doing. To tell you a little bit of what's happening in my area of responsibility, as I said, I'm running the technology platform development at SAP. What we're doing is everything from classical middleware that you deploy on premise, process integration software, business process management, portals, application servers, Java and others, development infrastructures. It's mobile technology, mobile SDKs, mobile platform to manage devices and applications. It's about our cloud platform. We have a platform as a service for developers, which is basically middleware in the cloud that we're providing to extend SAP solutions, build new applications, and of course everything that goes around user experience, UI technologies, collaboration, these kind of technologies we're doing. I've been with SAP for quite a long time, and 5 years ago we were also going through quite some challenges because the software product had grown extremely complex. We had more than, at the time, 2,000 developers worldwide developing our middleware platform, NetWeaver. And we were coming from a time where the company was originally, let's say, small. Practices were homegrown, and in the end, I would say we had, with 2,000 developers, we had 2,000 development methodologies that were somewhat applied within development. Everybody had their own way of approaching things. Everybody had their own way on how they tested software, how they developed software. And the whole thing started to become a big problem because we had to integrate a huge and complex product consisting of several 100 million lines of code. You had to integrate all the software. You had to make sure that every 2 years you could actually kind of ship a new product. That were the development cycles, 2 years. And this was becoming really a problem. We had huge and long requirements phases where we were spending with our internal stakeholders, our application development teams, with our customers, month, 5 months on seeking through requirements, everything being from a showstopper priority to a very, very high priority to a critical priority, and very few things then ended up on the, well, it's medium or low priority to get a certain feature done. Hot debates, hot fights over what gets into the next product release. Then the time we actually had to develop all those requirements were actually very short. So we ended sometimes up with, after having discussed thousands of requirements, delivering 20% of them. And then you figured out the guys had almost forgotten what they asked for in the beginning, and only 10% of what we delivered in the end were actually used by application developers. A big, big mess. That's when we started to rethink on how we develop software, and we started to look into lean and agile software development practices around the year of 2010. And we've completely transformed how we develop software internally at SAP. Completely moved into a Scrum-based approach. In my area, we have now more than 300 Scrum teams working in a single tucked and sprint cycle around the world in all the labs. We have labs, as I said, here in Sofia, we're in India, we're in Israel, we're in the US, we're in Germany. Many sites around the world, and we're building the whole product basically along the same methodology. Just to give you a background, and I'm going to tell you a little bit more about this as we go along. Now, I think for us developers, it's an extremely exciting time, actually, because what's happening is a lot of changes going out there in the world, in the industries. It's the digitization of the world that we're seeing, where atoms are turned into bits, where more and more business becomes digital, goes over the internet, where more and more millennials, digital natives, people who have grown up with the iPad and not just somehow figured out how to work it later in their lives. People who are mobile from their early years are starting to enter the business world, entering companies, becoming workers in those companies, and what they demand from software solutions that are provided by employers is quite different from what they were perhaps willing to accept a few years ago. So they come in with a perception on how mobile applications work, how you get instant access to any information that you need in the world via the internet. Why can't I get all that information within my company as well? Why do I need to wait a week for a report that tells me where we are with our business on a financial perspective? So very, very different situation today. Now, Stephen O'Grady has coined a term, developers are the new kingmakers. That's out of a book, The New Kingmakers, How Developers Conquered the World. And he claims that developers these days are more powerful than ever. And there's 4 reasons why this has changed so dramatically. First of all, there's the topic of open source that has become ubiquitous over the past years. And it democratizes basically how intellectual property in software is created and how it can be consumed. A few years ago, you had to go and license software to get your own development going, right? You had to purchase a development environment. You had to purchase a source code management system. Dramatic change these days. Second topic, cloud. If you were to start a software company a few years ago, you had to buy quite some hardware, servers, expensive. You had to set up networks. You had to manage all that whole infrastructure. You needed some IT folks to probably help you with that. Today, you go to the cloud. There's a vast capacity available to everything you're doing, and you're not kind of upfront paying the hardware. You're basically subscribing to what you use on Amazon Web Services or on Microsoft Azure or in the SAP HANA Cloud Platform, okay? So you subscribe to what you use. No upfront investments, but you basically use what you need, you pay for that, and if your business, if your idea all of a sudden scales and you see customers coming in, it's easy to get additional capacity in there. Third is the whole topic of internet communication and the fact that we're all connected. I have a colleague in my team, one of my managers, he has been with SAP, like myself, for years. He's working in the office. His son is a software developer as well. He moved to Taiwan. He's working at Starbucks. Well, not at a Starbucks employee, but he's sitting in Starbucks to work. He has his laptop with him, and he works for a few companies, and he works remotely with other people that are sitting somewhere else in the globe, maybe also in a Starbucks, okay? Last but not least, how you basically do the funding for your project, micro-investments, Kickstarter, the way how you afterwards can market your solution. If you think about the App Store that Apple basically introduced to the world as a concept, it's quite a different approach in how you can get your software afterwards in the hands of millions of people around the world. It's not that you need to kind of post your little software thing in some magazine on the right page, or put it in a newspaper, or start thinking very, very hard on how you can actually get it into the hands of your customers. Much easier to distribute software. So this led to the effect that software-centric companies, entrepreneurial companies, are really starting to be the winners. And if you just think about WhatsApp, it took them 60 developers to create a product that is now reaching 500 million people around the world. You couldn't have imagined that something like this happened 10 years ago, 20 years ago. Extremely hard to get a company that quickly up and running and getting such a broad reach. Or think Netflix, which is currently challenging cable TV providers around the world. Again, digital disruption happening to established businesses. But with all the power that the new kingmakers have, there come, of course, great responsibilities. Voltaire has said that, so that must be true. And this is why we're here, okay? This is why we're here at this conference. So it's all about building great software solutions. Now, if I ask you, what characterizes great software? What would be your answer? Good point. Working helps. Well, let's talk about it. There's many ways how we can look and characterize great software, okay, or great products in general. There's IDEO, the famous design company, and when they look at a great product that they want to design with their customers, they basically say you need to balance 3 dimensions. And the 3 dimensions are depicted here on this PowerPoint. It's desirability, it's the viability part, and the feasibility part. And if you want to create something successful, you have to make sure that all those aspects are well balanced around your product. And with the massive shifts that I've already talked about, there are quite some changes these days that impact those dimensions. And let me just give you a few ideas of what I talk about. If we talk about desirability, and I've given you examples already, customers today require that the software, as simple as it sounds, is easy to use. How much software are you using in your business, in your workday, that is not easy to use? I'm pretty sure there's a number of those things. So now you will need to have an intuitive user interface. You need to have it up and running on any type of device, any type of form factor, whether it's your mobile smartphone, your tablet, your PC, your laptop. You want it basically accessible everywhere. Take feasibility. Feasibility is what about the technology you need to put into place? What are the processes you need to put into place to get the solution done? So what is it built from? And there's new capabilities we talked about, like cloud. The topic like always being connected, wireless all over the world. The topic of embedded software. Just think about Internet of Things. Think of smart machines. Think of wearables, kind of these fitness trackers. Think about drivables, autonomous cars. Think about flyables, the drones. All these things require new ways to deploy software. It's not that embedded hadn't existed before, but now you get a much broader reach. The innovation cycle is much faster, and you have to think about how do I get my software update onto that device once I have shipped it to a consumer. I've been at a workshop at SAP Labs in the US where we had invited James Goslin, the inventor of Java, and he's working at a company, a startup now, which is Liquid Robotics. And what they are doing is they are creating devices, swimming devices, floating devices that you can put out onto the ocean, and they have all sorts of sensors and detectors. So they use that for tsunami detection, they use that for weather condition measuring. And what they basically do is they take a surfboard-like thing, they put a lot of hardware in there, hope that they can seal it from the salt water, They have to think about a lot of redundancy they put in, because if that thing is out on the ocean and something fails, you want it to be automatically failing over to new hardware. The whole software that you need to put into that thing is dramatically different, and you have to think about the fact that you're somewhere out on the ocean, you have a satellite link, and there's no megabits per second that you can kind of send over the satellite link, but you talk about kind of a few hundred bytes per minute at most, and all of that takes enormous energy. So these are the things that dramatically change how you think about these things, and that requires new ways of looking at software engineering and to change the style how you collaborate. And last but not least, the viability part. That's the business side. Okay, in the end, whatever you do, I mean, sometimes you do it just because you're kind of a friendly person, but most of the time, if you look at this, this is about business. We want to earn some money with it. So what's different now is you can, as a provider of a solution, you can go for a low-budget provisioning over the cloud. As I said, no big upfront investments. You get Amazon hardware and compute power basically for pennies. If you're a consumer, on the other side, you don't have to put all that money down as well. You can subscribe to the service. You pay as long as you use it. And if you don't like it anymore, you move on. And it's not that this software that you've bought is sitting somewhere on your shelf and all the money is wasted. There's open source and open standards you have to look into that you can use. You can think about the API economy, public APIs which you can use to create an ecosystem around the solution that you have created. Think just about the many solutions that tap into Facebook, that tap into Twitter, and extend the solution that is already out there. So you can attract much broader ecosystem for your solution. And in the end, it's a global and open market. I mean, if you're a software company here in Bulgaria, your market is not just Bulgaria, right? With today's technology, you can basically have customers all around the world. So you can have a broad reach in what you do. And that's dramatically different than what we had before. Now, these shifts in those categories also imply that we look at a few new best practices. And I will just try to talk about a few things that we're applying also at SAP that I believe are important in those categories. I need to go there. Another nice quote from Steve McConnell from Microsoft. Most software sucks. Anybody would agree in here? Hands up. Okay, we're kind of divided about this, but that's the feeling. Now, how do we address this at SAP? We try to, I mean, you can always come up with great new ideas, do a little bit of brainstorming, or just kind of code it, and they will digest whatever I have coded, no matter what, because I know it's great software, and they rather use it, or they leave. But frankly, the better way is to start working in a systematic fashion about the idea creation, the product design. And that's what we do with design thinking. That's a methodology that puts structure around a rather, let's say, creative and a little bit chaotic process of idea creation and innovation. It's about developing empathy with the end user of your software and to create ideas how you could do things differently. And we're moving away with that concept from just thinking about features to rather thinking about what's the experience that a user of the solution has in the end. Why is that? Because also IT organizations, if you talk to CIOs, in the past they could just, it was a technical job, get the solution deployed, they have to use it, period. Today, the money is not with the IT department anymore. The money is with the lines of business in the corporations. So the HR department in the end decides where the money is put. And if the HR employees don't like your software solution, it will not be bought. The CIO will not have the money to get that solution. So there's a lot of pressure to really understand the needs of the end users. There's three cornerstones in this design thinking methodology that are important. One is diverse teams. So don't only put developers in there. Take some designers, most importantly, take end users in that workshop again, work with them together. Get people with completely different background. Think about people who operate the solution afterwards. Take a salesperson in there to discuss on how you sell the software. So make sure there's a diverse group of people that jointly think about how the solution can be done, and design thinking actually has a very structured way and a lot of tools that you can use, and brainstorming is just one of them on how that is put together. Second is it's an iterative approach. seldomly you take the direct route from, well, we have to think about this problem, and then you take it once, and then you're at the end. That kind of thing seldomly works in real life, so you usually iterate. You start creating ideas, you refine your ideas, and move on. And last but not least is, what's very helpful is to have a creative space to actually do that. You can sit in a room without windows, with concrete walls around you, at a blank table, nothing around you, and start trying to be creative. I have a hard time to do that, and you probably as well. So think about a kind of environment where people start playing around with ideas, where they feel free to kind of raise stupid ideas, where they can start playing around with things. And that's what is part of that as well. And we're creating SAP app houses at SAP. We have several around the world. Which are these creative spaces? There's just some room, and there are some workshops going on where we bring either internal groups at SAP or also customers jointly to think about new solutions that we can actually create. And we do that since these app houses since 1.5 years at SAP. And we had more than 300 customer workshops going on in that environment where we actually bring in customers to create new solutions. Design thinking overall we do for roughly 4 years. Now there's another quote I want to give. I love quotes. If you want to make God laugh, tell him about your plans. That was Woody Allen. Now, I'm now coming to the topic of feasibility. Every software product starts with a software project. As I said in the beginning at SAP, and I think with many companies in the software industry as well, things were a few years ago, they were still pretty much waterfall. Try to come up with a long list of requirements, understand every detail, make a good plan, the better the plan, maybe put more effort into planning. This is the plan, we have to follow the plan, and at the end of the plan, you knew it didn't work this time as well. Next time we'll do it better. Now, we figured out, and many others as well, there's always better ways of doing things. That's why we moved to lean software development, agile software development, and I've just put up here the manifesto of agile software development. And I think that's very important aspects in there, and I'm pretty sure you all do that anyways. But we really value the topic of individuals and the interactions over strict processes and tools adherence. Doesn't mean that this side is not important, but if we have to choose where we put more effort, it's about individuals and interactions. And design thinking is just one of those aspects I talked about. We value working software over comprehensive documentation. I know developers love that. But it's really kind of getting the software working and making it easy and intuitive is much more important than telling somebody, you know, yeah, it's a little bit awkward how it works, but you know it's documented. Very obvious. Customer collaboration over contract negotiation. I talked about that extensively. Design thinking, how we do requirements engineering within the company. It took us 5 months in the past, in some areas sometimes. Now we're moving into the fact that we assign teams. So we assign capacity. We tell you, here's 5 Scrum teams who will work on your project, and you can be sure we're doing the best we can. And we tell you every takt cycle where we are, and you tell us what your most urgent kind of requirement is, so we work from the top of your requirements. So you can be assured we may not get everything done that you want, but we can exactly tell you what you get, and you know it after 1 sprint. And we have complete transparency on where we are, and you can change your mind as well as we go, dear customer. So dramatically different approach. Last but not least, responding to change over following the plan. I mean, just following a plan is sometimes pretty stupid. So you, of course, follow the change. And again, with Scrum and Agile software development methodologies, it's easy to change plans because you only look ahead to a certain extent. You don't think that the plan is so valuable that you can't change it, and you basically get early feedback from your stakeholders, from your users of your software after each sprint cycle, and you can actually see where you are. So we're using that extensively in our organization, and I have to say it had a dramatic impact on software quality and reliability of delivery dates, delivery scope, and I can tell you, while I had fights 5 years, 6 years, 7 years ago, with my stakeholders, there were always bloody meetings. It has completely changed the way how we work with those guys. Completely changed. The problem with quick and dirty is that the dirty remains long after the quick has been forgotten. Also a nice quote. Again, Steve McConnell from Microsoft in Project Survival Guide. Scrum alone is, of course, not enough. That's why we're looking into agile software engineering practices. Again, what you need is the technical development practices. Software engineering, while many people think it's an art form. I love that. I like that. I started as a developer myself. I like the creative aspect of software development. Where every evening you want to go tell your grandma on what you have done, and you don't know how to tell her how proud you are of what you've done. That's the art part of it. But in the end, let's be real. I have 3,500 people developing a highly complex product portfolio. In the end, you need craftsmanship to get it done. And software engineering practices are the craftsmanship of our industry, of what we're doing here as software developers. We're using Scrum, as I said. We have office spaces for teams, so we've also looked in how, if you work in Scrum teams, in a kind of diverse Scrum team, how do you have to kind of create the office space around those things, that people can really work as a team, that communication is supported, that people don't sit in offices far apart, and that there's always kind of a meeting in place to go to where you can do your daily stand-up meeting in the morning, or where you can do your review meetings or your retrospectives after the sprint. So you need to foster basically an environment where people can work as a Scrum team as well. We've even changed how we do performance ratings, how we do the MBOs of people, how we look at performance. If you value the team over the performance of the individual, and you want to foster that, it's a different way how you do things. One important thing that I felt was really kicking in nicely at SAP in my unit when we went to the Scrum approach is we moved away from 2,000 different development methodologies, every individual having their own one, to one defined one. And we said we do Scrum by the books. There's no SAP Scrum, because if you start that, you can also debate why not take something else. So we said we do Scrum by the books. The good thing is now, all of a sudden, you have teams who all follow the same methodology. Now, rather than having individuals go to a conference like here at ISTA and learning something about test-driven development, and then going back to their office the day after, looking at their colleagues saying, hey, I learned something great about test-driven development, and they all go, yeah, I know, but we don't do it here. It's a very different thing now, because now you can look at a team, and you can send the whole team to such a workshop, and all of a sudden they have all heard the great things about test-driven development, and they know we can fit it into the way how we develop software. And by the way, the other teams do it as well, and my employer actually builds tools and infrastructure around it so that we are supported in doing this. So all of a sudden there's a lot of kind of systematic push behind these things, a lot of things you can put into place that make it easier for individuals to take what they learn and put it to practice at their workplace. Okay? What else did we do? Continuous integration. As I said, hundreds of millions of lines of code make the middleware product at SAP. You have to integrate all of that stuff. Somebody has to test whether it still works. You have to install it, you have to upgrade it, you have to make sure if you get it to the customer, it doesn't fail and break, and that they don't have downtimes, and they need to, whatever, take their whole plant down for a weekend just to get your new software in. So it's about continuous integration. I always want to know where we are with our software. Does it still work? Not just the tiny bits and pieces. That's what we also do with unit testing, but also the end-to-end integration. So you need test automation. These things have to happen. Otherwise, you won't be able to kind of reintegrate and test the whole product and show the whole product after a 2 weeks Scrum cycle. Okay? Very important. Finally, we moved from on-premise middleware to the cloud. Now, cloud means something else. Now we're away from yearly product release cycles that we do on-premise. Now, every 12 months, we ship our middleware product, a new release. We move to cloud. Cloud now, we have 3-month milestones, so major features we put out in the cloud every 3 months. So you need kind of ongoing requirements planning, ongoing backlog, product backlog planning. You need to integrate continuously. And we actually push out minor features and, of course, bug fixes every 2 weeks, bug fixes every day if necessary, but minor features every 2 weeks. That means you also need to be able to deliver your whole software into a running cloud infrastructure, and you can't take it down. That requires a lot of adherence to software development practices, and you have many workshops here at ISTA to actually hear about these things as we move forward. There's in particular a session about continuous delivery here at the conference. Don't know which one, but there is one, so if you're interested. One more quote. No business plan survives contact with the customer. No plan survives contact with the enemy was, I think, the original, but this one from Stephen Gary Blank, who wrote the Startup Owner's Manual, is also very, very valid. That leads us to the third aspect of desirability, feasibility, that's the viability part. We're also using a well-known tool here at SAP, which is the business model canvas, which is a simple tool. It's a paper with a few categories on it that force you to think about certain aspects of the product and the solution that you are going for. A business model in general describes the rationale of how an organization, a company, creates, delivers, and captures the value of a solution. That might be in an economic sense, in a social sense, in our sense with software, it's usually in a business context. Now, the business model consists of several categories. There's the market category, where you have to think, of course, on what's the market out there? How big is it? Who's the competitors out there? Am I going for large enterprises? Am I going for the consumer space? How do I actually get access to that market? Do I need somebody to help me get into the door of the customers? Can I use a direct channel? How will I sell my solution in there? So you have to think about the market that you are trying to conquer. Sounds pretty obvious, but how often do you do that if you create a product? And that's a nice methodology to look at it. Second, what's the value proposition? How often do you see things where somebody has built something and is so enormously proud about it, and then you think, well, interesting, but it's not my problem. It doesn't solve any of my problems. So what's the value proposition of what you're doing? Are you really solving a real-world problem? Is there a group, is there an individual out there who wants your solution? Is there a group of people who would buy it? So what's the value proposition? Write it down. Can you formulate what the value proposition of your product is? And that's not easy. If you start doing it, it's really difficult. And you will figure out, maybe you started with one idea, and later on you figure out now people were actually, that's what I thought it would be used for, but people did something completely different with it when we ended up with it. You have to think about how are you competitive. If you're not alone in the market, and most of the time if there's nobody else in the market, there's probably no market. So there's always competition. So your product compared to those who are already established in the market, what's your value proposition over them? Next category is implementation. This has two aspects. Internally, do you have the right people? Do you have enough people? Do you have the people with the right skills to get it done? What hardware, what infrastructure does your solution require? Is it something you can deliver in the cloud? Will customers not go to the cloud with you for the problem because they want to have the data sit in their data centers basically within their company borders? Do you have to go on-premise? So what are the internal kind of things that kind of are constraints to the solution you're creating? External ones. As I said, can you work with partners? Do you have to do everything on your own? These are the things you have to think about. Cost structure, very important. Many great solutions. Think Transrapid, think Concorde. Great ideas. Wow, value proposition is there. It's fast. You can get to New York in less than 5 hours. But in the end, it may fail because, well, it's too expensive, it's too hard to maintain, it's outdated technology, and the effort to keep it up and running is so expensive that you basically kill your cost model completely. Today, for software, again, we have talked about it, cloud is one of the obvious things. You can think about open source. Are there things you can use that you don't have to pay for that will help you get your cost structure down? But you need to know what you're doing. Not knowing what the cost is of what you're doing will make it very hard for you to be kind of successful with your product in the end in the market. Last but not least, the revenue streams. As I said, is it a low price, but you go for many, many users? Is it kind of a high-value product you're creating? So it's fine if you only find 1,000 customers, if they all pay millions for it. Well, that's okay. You can earn money with that as well. What's the margin you're making if you look at your cost structure? Do they pay upfront, or do they want to pay as they go? If they pay as they go, how sure can you be about your business? How much commitment will you put into your business if you don't know whether the revenue is coming in or not? So that has a lot of implications on what you're building. What is important is you need to iterate on that one, and you need to iterate quickly. And that again means don't plan forever and think you will come out with a perfect product, but iterate. And that's exactly what's also happening with the business canvas. And that's why you need to get your first product, the minimal viable scope of your product, as quickly together, test it in the market, take the metrics out of the adoption, take the feedback of the customers, and iterate over your plan. Change it, adapt it. Don't stick to your original idea or be upset if it doesn't work out. Rather start thinking about what you can really do with the product. So these were the three categories. Desirability, somebody needs to feel that they need your product. The technical feasibility, can you actually build it reasonably well and maintain it and keep it up and running? That's where software quality, of course, plays a big role. And last but not least, the viability part. In the end, you want to make sure that you can make a living of what you're doing if you don't just do it for fun. So great software is more than bug-free software. Do you know when the term bug was actually coined? Wonderful, somebody knows. It was in 1947. 1947, imagine. It was Grace Hopper, by the way, one of the great women in software development. She coined the term because they were still working on electromechanical computers. It was the Harvard Mark II. Anybody remembers the machine? No? Okay, that's gone. They had a failure, and they were looking for the problem, and then they figured out there was a moth actually was sticking somewhere and had introduced an electrical short circuit, and they figured out it's a bug in the system that caused the problem. And since then, this is called bugs. And by the way, what you see here is the error log. Error logs today are something different, but this is the original error log, and they have put the moth on here with some adhesive tape. And you can see here the timeline, what happened in the system, and then here it actually says closed down, problem solved. That's the error log back in 1947. But Grace Hopper, by the way, she was a really smart woman, very impactful to the software industry because she invented the compiler. So what we're just using without thinking about it, she invented it actually. And she was also a co-designer of COBOL. Not a vastly popular language these days, but still one of the most used languages out there in the world, and there's still tons of systems, and if you're a COBOL consultant, you can make a lot of money because there's not many of you out there anymore. So, but she's even smarter. She also figured one more thing out, because she said the most dangerous phrase in the language, I think in any language, is "we have always done it this way." Okay? This is why you're here today. At ISTA 2014, learn something new, inspire others about what you're doing, and network with all the smart people here in the room. Have fun here, and a great day with lots of workshops, lots of presentations at the ISTA conference here. Thanks for your time, thanks for listening, and have fun and a great day. Thank you.
Let's thank Björn Goerke. The conference is starting in all three simultaneous tracks. So if you want to attend any presentation in track B or track C, you can take your seats now. Here in the main room, we have JavaScript performance analysis and testing by instrumentation by Agel Tudorov from Infragistics. In track B, we have extreme programming, and in track C, we have animate and automate from Mentormate.